All right, hi folks, this is Larry Mussolino. I'm recording a video for Module 12 in Math 181, and this is related to working with random variables and then probability distributions for those random variables. So why don't we start off talking about what is a random variable? Well, you could see here the definition is, oops, let me share my screen. All right, so I'm sharing my screen. This is the Module 12 lecture notes. So we want to discuss random variables. So here's the definition. It says here, when we run some kind of an experiment, we want to come up with a rule that assigns a number to each outcome. So let's do an example. What about if I roll a six-sided die? I might assign a random variable to be the number that shows up on the die. So for example, if I roll a 6, x would equal 6. I don't have to do it this way. I could assign the number 9 when I see a 6 show up on there. That's up to me to come up with the rule. How about if I select a person at random and X is the amount of memory on their smartphone? So maybe X is 128 gigabytes, for example. Maybe X is the commute time in minutes for people to commute to work. Maybe X is the yearly salary. Maybe X is the number of children in a household, or maybe X is the weight. So it's really up to me to decide how I want to assign this random variable for each outcome in some experiment. Now, one thing you might notice is as we're looking at these numbers for X, some of these numbers can only take on specific values. For example, if I look at the number of children, right, X could be 3, X could be 4, but I can't have X equal 2.6, right? I can't have 2.6 kids in a household. If you think about the memory capacity of a smartphone, that can't be anything because iPhones only come with very specific memory capacities allowed. Like for example, 64 gigabytes or 128 or 256. You can't go into a store and order a random amount of memory on your smartphone, right? You're restricted to these only possible values. We call this a discrete random variable. So a discrete random variable is when the random variable is restricted to only certain values. How about the weight of a dog? Well, really, I'm not restricted to any weight. That weight can be any number. You know, imagine you have a very accurate scale. It could be 14.7613 pounds. So we call this a continuous random variable. Continuous means it can take on any values. So notice here's the distinction. Discrete can take on only certain values. Let's say the number of cars in the parking lot. Well, that can only be positive whole numbers. Continuous can take on any value like the weight of a dog or the weight of a fish. So as we're discussing these random variables, you can think of them as either being discrete or continuous. Let's take a quick look at this listing here. Well, the number rolled on the die, I'm only allowed 6 values. So this is going to be discrete. The amount of memory, we discussed this is discrete because I'm only allowed to select from certain values of the random variable. Commute time. Well, this commute time could be anything, right? I'm not restricted to only a certain number of minutes, so this is continuous. How about a salary? Well, the amount of money is a little tricky because you might think it's really discrete because I can only have a certain number of dollars and cents, but really, if you think about it, I don't necessarily have to be limited to only, dollars and cents. Sometimes you might see at a gas station, the price of a gas of gasoline is shown as $2.579. So instead of just going out to the second decimal place, they go out to the third decimal place. But you can go out more decimal places. So usually we think of money as continuous. How about the number of children in a household? Of course, that's discrete. I'm only allowed to have a whole number of children. And the weight of a dog, we said, is continuous. All right, so this is the idea of working with random variables. We want to go a step, and by the way, here are some videos you might check out that explain more about random variables. We want to take another step, though, and form what's called a probability distribution. Well, the way we're going to start is we're going to set up a frequency table. We've discussed this before. So remember how you do this. You count the number of these data values that show up in your data set. For example, if I went around to 30 households, whoops, let me share my screen again. If I went around to 30 households and I asked them, how many children do you have? Here is the responses. So this is how many children under the age of 12. And you can see some families had 1 child, some families had 0, some families had 4, and so on. I want to organize this in a frequency table. How many families had 0 kids? Well, I would go to this table and count up how many zeros I see. Well, if I count that up, I'm seeing here's 1, here's 2, here's 3 zeros. So I'm going to put a 3 here. How many families have 4 kids? I'm going to count that up. Here's 1 4, another 4, a third 4. So that's the frequency. The frequency is just a count of how many households had that particular number of kids. Then we want to convert this into a probability distribution. And the way you convert this into a probability distribution is you take the frequency for each row, the count for each row, and divide it by the total number of data values. So in our example, we had 30. So the total number of data values is 30 in this example. So to set up a probability distribution, what I'll do is I'll take the frequency for each row. First row, there were 3 families with 0 kids. Divide that by 30. That means there's a probability of 0.10. That's like 10%. There's a 10% chance that a family will have no kids. There's a 40% chance that a household will have two children. So now we can answer questions. What's the probability that a household will have fewer than 2? Well, fewer than 2 children really means having just 0 and 1. Well, that's going to be these 2 probabilities added together. And if I add 0.1 and 0.3, I get 0.4. What's the probability that a household will have at least 3 children? Well, at least 3 means 3 or larger. Here's 3 or larger. That's going to be 0.1 plus 0.1, which is 0.2. So when you go into the WebAssign homework, you're going to see tables like this called a probability distribution, and you're going to be asked different probability questions. So what you have to do is really determine what rows correspond to the conditions given in the problem, and then you can calculate the corresponding probability. All right, so why don't we go do a few WebAssign examples? Hang on a second. Let me log into WebAssign, and we can work through some examples. All right, folks, I'm in the WebAssign homework for Module 12. So let's do a few examples here. Let me come here to number 3. So it's giving me a probability distribution table where they're giving me the value of the random variable, that's x, and then the probability in the second row. First question, what's the probability that x is greater than or equal to 0? So what I'm going to do here is circle the values of the random variable that fit that criteria. So these are the values that are greater than or equal to 0, right? 0, 1, and 2, those are all values greater than or equal to 0. So I'm going to add up the probabilities, 0.2 plus 0.2 plus 0.2 gets me the answer 0.6. What about the probability that x is less than 0? Well, less than 0 really means they want me to find these probabilities for x equal -1, -2. But I don't know what a is. But I can make use of the fact that the sum of the probabilities must add up to 1. So I know that these 2 probabilities, a plus a, must be the missing 0.4, right? Because these probabilities here in red add up to 0.6. That must mean these a's must add to the remaining 0.4. So that probability is 0.4. Well, if they're equal to each other, and I have an A, and they add up to 0.4, it must mean that each one of those probabilities has to be equal to 0.2. All right, let's do another example similar to this one. me scroll down a little bit. All right. Again, folks, I'm going to skip some of the examples that have a watch it there because I know you can watch those videos and get a good sense of how to complete some of these problems. So why don't we take a look at this one? So it says here, 3 fair coins are tossed, and X is the number of heads minus the number of tails. And they want me to come up with the probability distribution. All right, well, what I could do here is try to list out all of the different outcomes of this experiment. So why don't we do that? I'm going to list out 3 coins. So this is coin 1, coin 2, coin 3. And I can quickly list out all the possibilities. An easy way to do that is in this first column, I'm going to do 4 heads and 4 tails. By the way, I know there's 8 possible outcomes, right, when I toss 3 fair coins, because there's 2 outcomes for each coin. And if I toss it 3 times, that's 2 times 2 times 2. That's 8 outcomes possible. So I know I'm going to have 8 rows in this table. So an easy way to set this up is to make the first column be 4 H's, 4 T's. The next column, I'm going to have 2 H's, 2 T's. And then the third column, I alternate. So this is an easy way to just come up with all of the 8 outcomes when flipping 3 coins. All right, so now X is the number of heads minus the number of tails. So let's do that. So we're going to take the number of heads and subtract the number of tails for each row. All right, this is going to be 3 minus 0, 3. This is going to be 2 minus 1, 1. This is going to be 2 minus 1, 1. Remember, we're counting the number of heads minus the number of tails. This is going to be 1 subtract 2, that's negative 1. This is going to be 2 subtract 1, that's a 1. This is going to be 1 subtract 2, that's a negative 1. This is going to be 1 subtract 2, that's another negative 1. And this is going to be 0 subtract 3, which is a negative 3. Now I can make up a probability distribution, right? What's the probability of a 3? Well, it looks like there's just 1 3 out of 8 outcomes, so that's 1 over 8. What's the probability of coming up with a 1? Well, it looks like there's 1, 2, 3 1s out of 8. What about the probability of a negative 1? I'll count those up. There's 1, 2, 3 of those, so that's 3 over 8. And of course, the probability for negative 3 is just a 1 over 8, right? Because there's only one of those. All right, so that's how I'm going to fill in this table. Then I could just draw the histogram. All I have to do is make the height of the bars equal the probability. So if I scroll down here a little bit, remember, I need this to match up to 1/8, 3/8, 3/8, and 1/8. So only this histogram matches that. All right, let's go down here. It says calculate the probability that X is between -1 and +1. Well, if I calculate the probability that X is between -1 and +1, I'm really adding up these 2 probabilities right here. So they want this, the sum, right, between -1 and +1. So that's 3/8 plus 3/8. And 3/8 plus 3/8 is 6/8 or 3/4. So this probability is 6/8, which is 3/4. All right, so let's go down here a little bit. Let's do one of these examples with income distribution. All right, so what they want me to do is figure out the probability for each one of these number of households. Well, the way I'm going to do that is add up and get the total. And then let me find the probability that someone makes between 0 and 19,999. Well, that's going to be taking this entry, 240, and dividing by the total. All right, hold on a second, folks. I need to get my dogs calmed down. Bear with me a second. All right, folks, let me do a few more examples here. Is a data table, and it's showing the towing rating for different vehicles, okay? And the first question is, what are the values of the random variable X? Well, I'm really just going to list out these values that I see, 2,000, 300, 4,000, and so on. I'm going to list out the unique values that I see here. Then they're going to ask me to come up with a frequency table and a probability distribution. All right, well, all I have to do is count up the number of 2,000s in this table. Let's do an example. How about counting up the number of 8,000s? Well, there's 3 of them. So I'm going to put a 3 here. How about the number of 7,000s? There's no 7,000, so I'm going to put a 0 here. How about the number of 6,000s? There's 2 of that data value. Then I'm just going to divide to get the probability, to get the probability, I'm just going to divide that frequency by the total number of data values. So if I come up here and I count how many data values, I think there's 10 of them. 2, 4, 6, 8, 10. Yeah. So this probability here for 8, this probability is probability of 8,000 is taking that frequency 3, dividing by the total number of data values 10. So this is 0.3. Okay. So I can easily fill in this table. And then here's one more question. What's the probability that a vehicle is rated to tow no more than 6,000? Well, no more than 6,000 really means 6,000 or less. So for this question, they're really asking me to add up these probabilities here in the blue. And if you add up those probabilities in the blue, you get 0.7. Okay. By the way, remember the words no more really translates to a less than or equal to symbol. When I say no more than 6,000, I really mean less than or equal to 6,000. All right, let me scroll down and see if there's anything else that's a little different. That's similar. I think this is going to be similar. Let's do this one here because this one's a little different. But we're going to just set up a table. And instead of counting each unique value, I'm going to calculate the numbers that are in the intervals. So here's what I'm going to do. I'm going to calculate how many of these data values fall within 1.1 to 2.0, and then 2.1 to 3.0, and then 3.1 to 4.0. All right. All right, well, let me count up how many numbers are in the interval from 1.1 to 2.0. Let me count them up. Here's one, here's one, here's one. Again, I'm counting numbers that are between 1.1 and 2.0. And I think that's it. And you can see there's 5 of them. Then to calculate the probability, I would take 5. So let's calculate this probability here. This would be calculated as 5 divided by the total data values. Looks like I have 20. So 5 divided by 20 would get me 0.4. I'm sorry, 5 divided by 20 would get me 0.25. So you could see how we're coming up with those probabilities. All right, folks, hope this is helpful as you're getting started in the homework here in WebAssign.